I'm going to go through some of the calculations and how to do them for the Monterey Bay Aquarium Biomagnification Lab. So in the previous video, I explained how students are going to have a different card. And we have 5 different cards here for students. So some are zooplankton, phytoplankton, sardines, salmon, and then we have 1 human. Let me find my human. You want to make sure that you have most being phytoplankton, even though that's not quite as much fun for the students. They don't really want to be phytoplankton. They want to be something more interesting, but you need more phytoplankton. And then a little bit less zooplankton, and then a little bit less sardines, a little bit less salmon, and then a human. So if I have a full class of over 30 students, I'll have 1 human, maybe 2 or 3 salmon, 5 sardines maybe. You know, I kind of mix it up a little bit to see how the numbers go from class to class. And then I'll give you a little bit closer up of what they're hunting for in the ocean. So first the phytoplankton go, and you can spread this out outside. You can spread them on a lab table. And they're going to hunt. I don't bother to turn all of these over. It doesn't really matter that much. And so they're going to hunt for as many of these as they can get. So they're going to pick up a lot of molecules, but they're really counting their POPs, persistent organic pollutants. So at the end, let's say that out of all of these, one of my phytoplankton students picked up this many. So we don't care about the H2Os or the bromines or the hydroxides or anything like that, or the oxygens. We want the POPs. So you're going to give them about 5 minutes after, so they hunt for, you can decide 30 seconds or whatever. And you can make it a minute. You can make it less time if you want. Okay, so this is the POPs from this 1 student phytoplankton. So they're going to add them up. 1, 2, 3, 4, 5, 6. Oh, and then 25. So 31 POPs. So what they do is these are taken out. They're gone from the ocean. And so this student has 31 phytoplankton, and all of these are gone from the ocean too. And so my phytoplankton students, and I might have 12, 13 of these students, they go back to the ocean and they hold their card with their sticky note. And so next, the zooplankton go and hunt. So the zooplankton students come and they can go and they're going to eat the phytoplankton. So as many phytoplankton as they can eat. They're going to, by eating them, they take their sticky note. And I tell the students, this is not a race. You can't hide it. You can't run from them. That's not the point of this. You're going to get faulty data if they try to escape. So that's not the point of this. So they're going to grab this, and then they're going to hunt for more of the ones that are left in the ocean. So your phytoplankton did not get them all out of the ocean. So let's say the zooplankton grabbed 31 from 1 phytoplankton, and this was a fast zooplankton, and it grabbed 16 from another phytoplankton, and then it grabbed all of these from the ocean. So the zooplankton, give them a few minutes. They're going to count up all of their sticky notes that they ate from the phytoplankton, and then they're going to count any more POPs that they may have picked up from the ocean in that 30 seconds. Okay, so we have 5, 6, 11, 12, plus 16 is 28, and 31 is 59. I think I added that correctly. So now these sticky notes are done. They can go in the garbage. These go to the side. They're out of the ocean now. And now this zooplankton had a total, I think I added 59, I don't remember. But 59 total POPs. So the zooplankton is going to go back to the ocean, and now the sardines are going to hunt. And the sardines are going to hunt and get as many phytoplankton sticky notes as they can, and more of the POPs from the ocean, and so on and so forth. Okay, so let's say that we're this zooplankton, and the zooplankton had 59 POPs that it got in total. So the first line here is just the student's own organism. So if this student is a zooplankton, they're going to write their 59 here, and they're going to leave all of the rest blank. Okay. Now you're going to end up adding up everybody in all of the trophic levels. So all of the phytoplankton, what I have them do is I have them put their individual totals on the board. And so we get class data that way. And so an example might be all of your 12 phytoplanktons, all of their sticky notes added up to, and you stop and get their class data, all of their sticky notes, put it on the whiteboard or something before the next level hunts. So get all of their sticky note numbers and add them up, and it might be something like 177. Okay, and then you're gonna take every zooplankton and you're gonna add them up, and it might be something like 280 because they captured all of the POPs from all the phytoplankton, but then they hunted for more in the ocean, so this number will be higher. Okay, and then the sardines, all of the sardines, I might have 5 sardines, and their numbers might be something like 335 for these guys. Actually, this is real data from a class, so let me give you this number. So I have it here written down. It looks like in this class period, I had 17 phytoplankton, and they had a total of 177. I had 7 zooplankton with a total of 280. And then 6 sardines with this total. And then it looked like my 3 salmon only hunted the sardines, and they picked up a bunch of blue papers that were left. See, by the time you get to the salmon, there's not very many of these left in the ocean. And so whatever ones they pick up might not actually be POPs at that point in time. So it looked like in this case, when I ran the simulation, there wasn't. And then the one human went and got all 3 of the salmon's sticky notes, and it looked like this human was able to hunt in the ocean for whatever was left and ended up at 340 POPs. So now we're going to average them out. So this is some real data from my class. It looked like this was a really big class. This had 34 students, if I'm adding quickly in my head correctly. So I hope that makes sense for you how to run the simulation. Okay, so the average number of POPs per organism, so we're just going to divide and round to the nearest whole number. So 177 divided by 17 is an average of 10. 280 divided by 7 is an average of 40. 335 divided by 6 is an average of 56. And this is an average of 112 and an average of 340. So that's what this number 2 tells us to do. And then down here, I do not have the students answer 3 because this original lab was designed for middle school. So I feel like these questions are a little bit low level and a little bit redundant for the AP level, so I just have them skip it, and they're always happy to skip questions. You know, they respect the fact that you don't make them answer questions that don't stretch their brain too much. I'm sorry, that they're a little more advanced for those questions, so they appreciate that. Okay, and then on the next page, that's pretty self-explanatory. They don't need me to run through here. I just tell them to read the directions and fill this in. So in the energy pyramid, we're going to write the organisms' names next to the consumer type and how many there were of each organism. So up here, our top predator, there was one of the top predator. And there were, let me look back at my data. I have it on another page. There were 3 salmon and 6 here, 7 here, and 17 here. And this was just the number. This is not really technically energy. It's not talking about kcals of energy like we do when we talk about trophic level. That's a little bit higher level than middle school, but we can talk about that here. It's a little bit of review, especially these terms here. This should be at review at this point in time. And then our toxins, we had 340 POPs here, 112 here, 56, 40, and 10. And so that is pretty clear for the students. And these questions are good questions to answer. So, you know, compare, it's inverted, that sort of thing. Okay, so this is pretty good questions for them to think about and answer. Not particularly difficult. Then we have some nonfiction text for students. So this is not a particularly difficult nonfiction text, so I don't need to do any kind of literacy help for my students with this. It is written at the middle school level, but if I was teaching middle school, I would have some literacy helps in here, maybe some annotations or some sort of graphic organizer for the students, or read aloud in pairs if I had English language learners. And you can do some of that too in your classes if you have some English language learners. There are some high vocabulary in here, and you could have them read aloud to each other. For my students, I don't have very many English language learners, and on the occasion that I do, they are usually, maybe not, they haven't passed the test to be not classified, but they're very high level functioning at this point in time. So I just say read and highlight or read and underline the reading. Okay, and so on the back, this is more of our science practices for mathematical calculations. And so here we have the math problems. I have a key for the math problems in the Google Drive for you so that you can see how the problems are set up and solved. All right.